Hello class, I hope you're all doing well. Today we're going to get started on a new unit, and this unit is all about linear inequalities. So far we have been working with linear equalities or linear equations. And these always look like y equals 3x plus 4, for example. We have that equal sign. But a linear inequality, it's the same thing, only instead of an equal sign, we end up having an inequality symbol. So there's 4 different types. This first one is greater than or equal to. Then we have less than or equal to. Then just greater than and less than. So there's 4 different types that we can use here. So let's define our linear inequality. So just like I said, it is like a linear equation or linear equality, but instead of an equal sign, we use inequality symbols. So one of those 4 that I mentioned up here. So then the solution to a linear inequality, it's the points, and points are always x comma y, that make the inequality true. So let's see what I mean by that. So I have an example right here of an inequality, and we have 4 different points. So I want to see whether or not those points are solutions. So this is our x comma y pair. X is 2, y is 5. So I'm going to plug in those values in for x and y in my inequality. So 2 times 2 minus 3 times 5 is less than 15. All I did was take this inequality and replace x and y with the numbers from my point. So 2 times 2 is 4, minus 3 times 5 is 15, is less than 15. 4 minus 15, that's negative 11. So we want to see whether or not this statement is true. Is negative 11 less than 15? Well, of course it is. So we say yes, it is a solution to that linear inequality. Let's try another one. This time x is negative 1 and y is negative 7. So we're going to plug those values into our inequality. So 2 times negative 1 minus 3 times negative 7 is less than 15. 2 times negative 1, well, that's negative 2. Negative 3 times negative 7. 2 negatives multiplied together gets us a positive, so this is adding 21. And then negative 2 plus 21, we want to see, is 19 less than 15? I say no, so it is not a solution to that inequality. For those next 2 points, I'd like you to try that on your own, on your paper, and then check back with the video to see if you were right. Let's check our answers. So x should be 3, y should be negative 4. We're going to plug those in. So 2 times 3 minus 3 times negative 4 is less than 15. We have 6. And negative 3 times negative 4, that's going to be positive 12. So we have 18 is less than 15. That's not true. So we say no, it's not a solution to our linear inequality. Last one, x is 0 and y is 0. We're going to plug those values in. So 0 minus 0 is 0. So is 0 less than 15? Yes. So 0 comma 0, that point, is a solution to our linear inequality. Okay, the next thing that I want to show you guys is how to graph a linear inequality. So it's very similar to graphing lines. graphing linear equations. The first thing we want to do is put our inequality into slope-intercept form. So let's remind ourselves of slope-intercept form. That's y equals mx plus b. And the m is our slope, and the b is the y-intercept. Okay, next thing that we want to do, once we have all of our points on our graph, we want to connect them with a line. So we might use a solid line, or just a normal filled-in line, whenever our symbols look like this. Less than or equal to, or greater than or equal to. As long as they have that little line underneath, we're going to connect our dots with a solid line. Otherwise, we would use a dotted line if we have the less than symbol or the greater than symbol. So notice how these two do not have that little line underneath. They don't have that extra part that means or equal to. Okay, once we have our points connected with a line, solid or dotted, we're going to shade above or below the line. So we can shade above the line if our symbols point in this direction. It doesn't matter if it has a line underneath or not. As long as it's pointing in that direction, we shade above. Alternatively, we know we should shade below the line if the inequality symbols point in the opposite direction. So let's see this in action. Let's try an example. So first thing, step one, we need to put our inequality into slope-intercept form. So that means the y needs to be by itself. And that's not the case here. We have all this stuff out in front of the y. So first thing, let's get rid of this 2x. We can do that by subtracting 2x from both sides. That makes this go away. So we have negative 3y is less than 15 minus 2x. Okay, next thing that we can do is to get rid of this negative 3. So what I want to do is divide everything by negative 3. One key thing to note here. We want to flip the inequality symbol if we divide by a negative number. So let's make a note of that off to the side. So when you divide by a negative, you have to remember to flip the symbol. So here, we're dividing by negative 3. So then this inequality symbol has to face the other direction now. So the negative 3's go away, and we have y now is greater than 15 divided by negative 3. Well, that's just negative 5. And then we have negative 2 divided by negative 3. So negative 2 divided by negative 3. I have a negative being divided by another negative. That just turns into positives here. So we're going to write positive 2 over 3x. I always want my slope to be a fraction, and it is a fraction here. Our slope is always the number in front of x, and then our y-intercept is always the number without the x. So negative 5 is our y-intercept. Now that we have this, we can graph. So my y-intercept is negative 5. That means on the y-axis, I'm going to find negative 5 and put a point. And my slope is 2/3. So that means go up 2 and to the right 3. So I'm going to go up 1, 2, and over 3, and I'm going to put my next point. I don't have any more room on my graph to put any more points, but all I need is 2 points. I can fill in the line. So, based on this inequality symbol, I know that we have to use a dotted line. because it doesn't have that little line underneath. And then, based on the direction it's pointing, I know we need to shade above the line. So everything above the line gets filled in. And that's it. We have successfully graphed our linear inequality. Let's turn to the back. So question 1, we are already in slope-intercept form. So notice we have the y by itself here. So we can continue on to step 2. This -5 here is our y-intercept because it's the number without the x. And this 1/3 is the slope because it's the number in front of the x. So that means we need to put a dot at -5. And this slope of 1/3 means we go up 1 and to the right 3. So we can put another dot. We go up 1/3. We put another dot. Up 1/3. Another dot. So I can already see a straight line being formed by these dots. And I've run out of room, but I can start going the opposite direction. I would just need to do the opposite of what I was doing. So instead of going up 1 and to the right 3, I can go down 1 and to the left 3. And then our straight line is continued. So I can keep doing that until I run out of room. Okay, let's look at our inequality symbol. That symbol tells us we're going to use a dotted line. And based on the direction that it's facing, we're going to shade above because our inequality symbol is pointing in that direction. So we're shading above. And I can always reference what I need to do by looking in this section here. This tells me everything I need to know. Okay, so we filled in that graph. Let's move on to the next one. Question 2. Once again, we already have this in slope-intercept form. So we just need to fill in our graph. We have our y-intercept, and -2 is our slope. So we're going to put a dot at -1. And this slope of -2, I always want my slope to be a fraction. And I can make any number a fraction by putting a 1 underneath. So what this is saying is go down 2 and to the right 1. So let's talk about that a little bit up here. Let's say I had -3/4 as my slope. That negative on the top means go down 3 and then go right 4. And what if I had +3/4 as my slope? That means go up 3 and to the right 4. The only thing that the negative changes is whether you go up or down. So if it's negative, you go down. If it's positive, you go up. So back here, that -2 tells us to go down 2 and to the right 1, and we can put our next point. So let's keep going down 2 over 1, down 2 over 1, and we can keep going with that, and same in the opposite direction. Instead of going down 2 and to the right 1, we can go up 2 and to the left 1. And we can keep filling in our graph. All right, now based on this inequality symbol, it has that little line underneath. So we're going to make that a solid line. And based on the direction that it's pointing, we know that this has to go below the line. We're shading underneath the line. Okay, let's look at an example that is not in slope-intercept form. So the y is not by itself here. We have to fix that. So we can subtract the 5x. That makes this go away. So we have -2y is greater than 12 minus 5x. we need to get rid of that negative 2, so we're dividing by negative 2. This goes away, and remember, when you divide by a negative, the sign has to point in the other direction. So 12 divided by negative 2, that's negative 6, and negative 5 over negative 2. Two negatives make a positive, so we're just going to turn this into 5 over 2. Okay, negative 6 is our y-intercept. So we're going to put a point right there. And our slope is 5 over 2, so that means we go up 1, 2, 3, 4, 5, and over 2. And we can put our next point. Let's keep going with that. We're going to go up 1, 2, 3, 4, 5, and to the right 2. We put another point. 1, 2, 3, 4, 5 over 2. And that's all the points I can fit on this graph. So based on what my inequality symbol is telling me, I know that this has to be a dotted line, and it's shaded below the line. So I only want to look at that final inequality symbol here. I don't care what this one says in the beginning. If it changed, this is the one we're going off of. Okay, question 4. Once again, we need to get y by itself, so we can subtract the x from both sides, and we get negative 4y is less than 8 minus x. Right, we need to divide by that negative 4. And because we're dividing by a negative, that sign needs to face the opposite direction. 8 divided by negative 4 is negative 2. And negative 1 over negative 4, those two negatives cancel out. We get positive 1 over 4x. Okay, and now we can graph. We're going to put a dot at negative 2. We're going to go up 1 over 4 to put our next dot. And we can keep doing that, including on the other side. So because of my inequality symbol, I know that I need to use a dotted line here. And it needs to be shaded above the line. So everything above the line gets colored in. Okay, number 5. Once again, we need to get rid of this x from both sides. So we have negative y is greater than or equal to 8 minus x. Anytime I have a variable without a number in front, I can call it 1. So we're dividing everything here by negative 1 to make this y be by itself. So we have y, and because we're dividing by that negative, we're flipping this inequality the other direction. Negative 8, and negative 1 over negative 1, well, that's just positive 1 over 1. And I know it can be kind of silly to write 1 over 1 as a fraction because it's just 1. But I like to keep my slope as a fraction because it helps me when I'm graphing. Okay, let's put a point at negative 8. And then we can go up 1 box and to the right 1 box for our slope to put our other points. Okay, based on my inequality symbol, it has that little line underneath, so that means I'm using a solid line. And this is going to get shaded in below. Next up, let's subtract that 3x from both sides to get y by itself. So we have 2y is less than 0 minus 3x. And we want to divide by the 2 to get rid of it. So notice here, I'm dividing by a positive number. The only time we have to flip this symbol to the other side is when we're dividing by a negative. We're not dividing by a negative here, so we don't need to worry about that. this inequality symbol will stay facing the same direction. Okay, 0 divided by 2, that's 0. And then negative 3 divided by 2, well, that's just negative 3 over 2. All right. The 0 is our y-intercept. This negative 3 over 2 is our slope. We're going to put a dot at 0 or at our y-intercept. That slope means to go down 3 and to the right 2. So we go down 3 to the right 2, down 3 to the right 2, and I can go the opposite way as well. So based on my inequality symbol, this is going to be a dotted line, and it's going to be shaded below the line, so underneath the graph. For question 7, I want you to notice that this inequality looks different than the ones we've been working with so far. We have a y, but there's no x. So in this case, we are going to end up having a horizontal line. If there's no x, that means we have a horizontal line. So let's graph this. I want to put a dot at y equals negative 4. And I'm going to put my horizontal line here. So it's always going to be this way. And now we want to see where we're going to shade our line. So this is easy. We could say that, oh, this goes below our line. But if we have a vertical line, like we'll see in our next example, it's kind of hard to tell what's above or below a line that's straight up and down. So we could have also done something called a test point. Just like we saw in these examples here where we had these different points and we wanted to see whether or not they were solutions, we could also do that with our test point. So I want to try the test point of 0, 0. That means x is 0 and y is 0. So if I plug in 0 for y up here, we get 0 is less than or equal to negative 4. So is that true? Is 0 less than or equal to negative 4? Well, no, that's not true. Negative 4 is the smaller number. This point of 0, 0 is not a solution. So just like we saw over here, if we determined yes or no, they're solutions or not, whether or not something is a solution tells us a lot. It tells us whether or not it's in the shaded part of the graph. So we ended up shading below the line here. That means at any point I pick over here, if I plug in those x and y values into my inequality, it's going to make it true. Like, let's try one. This point in particular is negative 1, comma, negative 6. So if I plug negative 6 into my inequality, well, yeah, that's true. Negative 6 is less than negative 4. So any point I pick here, it could be any one, it's going to make this inequality be true if I plug in those numbers. But any point I pick up here, anywhere, it's not going to make the inequality true. It's going to be a no, it's not a solution. So that helps us out when we're doing a vertical line. So notice over here, we have an x, but there's no y. When there's no y, that tells us we have a vertical line. So we're going to go over to where x is 7. That's right here. And based on this inequality symbol, we're going to make a vertical dotted line. Okay. So that symbol tells me we need to shade above, but what exactly is above this line? Because it's a vertical line, it's kind of hard to tell. That's when we can use our test point. So I always like to use 0, 0 as a test point, just because zeros are easy to work with. So in this case, x is 0. If I plug in 0 for x, is it true that 0 is greater than 7? Well, no, that's not true. So because this is not a solution, it can't be in the shaded part of the graph. So that means the only place the graph can be shaded is on the other side of the line. So a big takeaway here is that the solutions are all in the shaded part of the graph. If it's not a solution, it's not going to be shaded in. All right. What I'd like you guys to do now is do this page of practice problems. Instead of making it front and back, I just made it the front. I want to make things easy for you guys so you don't spend a ton of time doing this, because I know you have a lot of work from all your other classes and from your IS teachers. But still, we need to do questions 1 through 6. Once you're done with that, you're going to take a picture or scan it using the Cam Scanner app to make it a nice PDF, and you'll submit it to Google Classroom.